Okay, so we have what is the Lewis structure of Br3 and why does it not follow the octet rule? Okay, so Lewis for Br3 and why not octet rule? So first you have to figure out how many electrons each element contributes. So boron is on column 13, so that's 3 electrons, and bromine is on column 17, and that's 7 electrons. So we have 7 times 3 because there's 3 bromines, so that's 21, plus that boron, so that's 24 electrons total, okay? Now before we just jump over to draw the Lewis structure, let's understand what's happening with boron. So as we said, it has 3 valence electrons, so it's going to look like this. So with the whole concept of bond, it's when pretty much one unpaired electron is able to now bond with or attach itself to another unpaired electrons. For boron, it cannot do the I guess octet rule because in its outer shell it only has 3 electrons, so there is no quote-unquote 4th electron for it to bond with something else in order to produce the octet rule. For example, look at carbon. Okay, carbon has 4 valence electrons like that. You see how it gives itself space to even do the octet rule? That will be a reason why. You would even see things like beryllium, for example. That one doesn't follow the octet rule because it only has 2 electrons, so it would only really be able to make 2 bonds, and it'll be completely satisfied with that. So that's just what we're dealing with here in regards to boron. Boron is just one of those. Typically when you're looking at the periodic table and it's before column 13, or specifically column 1, 2, and 13, because transition metals, those ones do very weird things. It can be quite unpredictable, but at least for columns 1, 2, and 13, they're completely, at most cases, satisfied with not following the octet rule, as you can see with boron. Okay, so that being said, now we're going to fill in the information. It's going to have 1 bond, as you said, 2, and 3, with the bromine here, and here, and here. Okay, and then we're going to figure out just by filling in the rest, because you see the bromines follow the octet rule, okay, but the boron doesn't. Alright, because all I'm doing right now is filling in how many electrons are left, because right now the bromine shared 1 of its 7, so that's how we have 2, 3, 4, 5, 6, 7, and coincidentally that is following the octet rule for specifically the bromine, not the boron. And you can see here when we count the electrons, we do indeed have 24 electrons. So this checks out in every way. This is going to be the Lewis structure for boron well, I guess it would just be boron bromide, because boron is technically a post-transition metal. So that's what we have here. That's actually what we see in the picture as well. So the octet rule is satisfied for the bromine, but boron is an exception because it only has 3 electrons that it was able to share, so it would only have 6 electrons total. So with that being said, just as how I showed carbon, that one would follow the octet rule. Beryllium wouldn't follow the octet rule, and there's really no way to redistribute this to where boron can follow the octet rule and something else in this molecule would. I mean, where boron would follow the octet rule, but then that would mean something else in this molecule wouldn't. So like for example, if you moved I guess an electron pair from here to here to where boron could follow it, now the bromine isn't following the octet rule. And it's even worse for the bromine because it actually started with 7 electrons, so it really just needed 1 electron to not follow the octet rule. So there's like no situation to where it would willingly want to even give up those 2 electrons, because like I'm already fully stabilized, why would I want to transfer it over here? And boron on the flip side is like, I don't have space for this because I only had 3 lone electrons. So that is how we have this form, and that is why it doesn't follow the octet rule. So be on the lookout for things that are attached to other things that are in columns 1, 2, and 13. The most common one you see in column 1 typically is hydrogen. Hydrogen is a perfect example of doesn't follow the octet rule because it just has one electron to give. So it usually just forms one bond, just like that. So with that being said, this is correct. Now let's move on to the next question. With that though, let's take a quick